So now that we've talked about how to just look at the slopes and tell if two lines are parallel or perpendicular, we're going to start practicing that concept with a bunch of different examples and looking at the different ways that they can give you information and how you can use that information to tell if the two lines are parallel or perpendicular. So we're going to kind of carry on from the last video, and we're going to do a couple more examples just looking at the slopes. And then in the next in the end of this video and then in the next couple videos, you'll learn a couple other ways to look at different ways that they give you information, and then how to use that information to tell if they're parallel or perpendicular. So with this one, the question says, are these lines parallel, perpendicular, or neither? And when they say neither, what they're really saying is that those two lines are just intersecting, okay? So there's nothing really special about them. They're just crossing in some way, okay? So when we look at example number 1, notice they're giving us the slopes because that's what M is. So they say the slope of one of my lines is 1 over 4. So remember, slope is rise over run. So that means you're going up 1 and over 4, or right 4 to graph that line. Versus this one, the slope is negative 4. And so that means, like, if you think about that like a fraction, that means that that's like negative 4 over a 1. So that means rise over run, you're going down 4 and right 1 to graph that line. So if you're trying to tell are they parallel, perpendicular, or neither, it's really easy to tell if they're parallel, because if you remember, parallel lines have to be exactly the same slope. So the number has to be exactly the same. And if you look at these, 1/4 is not the same thing as negative 4. So you know right away that they're not parallel. So then how do you tell if they're perpendicular? Remember, perpendicular, they have what are called negative reciprocal slopes. So that means the signs have to be different. And then if you think about it like a fraction, the fraction has to be flipped from one another, okay? So that's what we're going to check here, because if it even remotely looks close, you want to check that. So if I look at this one, that is 1 over 4, okay? So then to be perpendicular, they have to have that fraction flipped, and they have to have a different sign. So if I, for instance, flip that fraction, it would be 4 over 1. And then if I change the sign, it would be a negative 4 over 1. And notice that is what we have here. And so these two lines would be perpendicular. And you can write perpendicular, or you can write the symbol for perpendicular, and that would be fine, okay? So those are perpendicular. Well, what about number 2? I'm going to check for parallel first, just because it's easier to do that. So if I check for parallel, they have to be exactly the same. Well, they're both 2/3, but notice this one has a negative and that one doesn't. So that means that those are not parallel because they're not exactly the same. So then let's check to see if they're perpendicular. So again, the fraction has to be flipped and the sign has to be different. So the signs are different, but notice if I flip 2 over 3, I get 3 over 2, and that is not that one, right? So these wouldn't be parallel, they wouldn't be perpendicular, so then your only other option would be that they're neither. And so if the question said, are they parallel, perpendicular, or neither, you would put neither. Or they might say, are they parallel, perpendicular, or intersecting? And if they did that, then you would put intersecting, because that means these two lines would cross. It just wouldn't cross at a 90-degree angle, okay? So the last one here, with just the slopes, it says the slope of this one is 3 over 6. So that means you're going up 3 and right 6 to graph that line. Here, the slope is 1 over 2. So that means you're going up 1 and right 2 as the pattern to graph that line. And so we're going to compare them. So again, check to see if they're parallel first. Are they exactly the same? If you kind of looked ahead, though, you'll notice that 3 over 6 is not reduced. You always reduce fractions. So before I look at this, I'm going to reduce this fraction. So what number goes into both 3 and 6? 3 does. So you divide each one of these by 3. So it goes into 3 one time. 3 and the 6 goes 2 times. And then you can compare them. So if the slope of this one's 1/2 and then the slope of that one's 1/2, notice they are exactly the same. So that means that these two lines would be parallel. And either you could put the word parallel or you could put the symbol for parallel. Okay, so that's just looking at slopes. Well, what if instead they gave us the equations of each line and you had to tell if they are parallel, perpendicular, or neither? Well, remember, you have to find the slopes of your lines. And so when you're given an equation, the first thing you want to do, or your first goal would be to find the slopes. So like if I look at this first line right here, it is in slope-intercept form. And so if you think about slope-intercept form, y equals mx plus b, the slope is the number in front of x. And so in this problem, 1/2 would be my slope here. And so you could circle it, you could write it to the side, however it draws your attention to it. And then here, that one's not in slope-intercept form. So before I can find my slope and be sure about my slope, I'm going to put it in this form. And so if you look, the y is by itself, but notice that x part is kind of behind. So I'm just going to rewrite it, and I'm going to bring the x part in front. So it'd be 1/2 x, and then my plus 7 would go behind. Okay, so I'm going to look for the slope just like I did here. It's the number in front of x. So that would be my slope here. So you can write it to the side, you could circle it, but then you compare them. So notice they are exactly the same. So these two lines would be parallel. Okay, so then here, in number 5, notice this one's not in slope-intercept form, so I'm going to put it there. The y is not by itself here, and I've got a minus 4x with it, so to get it to the other side, I'm going to have to add my 4x so that I can get my y by itself. Okay, so when I add 4x to each side, I'm going to write it over here. Negative 4x plus 4x is 0, so those go away. I have my y by itself, so I'm going to bring it over. And then I'm going to go ahead and put it in that form. So I need the x part first. So I'm going to put the 4x in front, and then my plus 5 goes behind it. Okay, so now from here, I can easily see that my slope, the number in front of x here, is 4. So my slope for this one is 4. Okay, so then let's look at this other one. It actually is in slope-intercept form. It just doesn't have the y-intercept there. It would technically be, because it doesn't have it, it'd be like a plus 0 there. So the number in front of x is 1/4, so that's my slope. So again, you can write it over so you can compare them. So my slope here is 1/4. All right, so are they parallel, perpendicular, or neither? Well, they're not parallel because they're not exactly the same number. Perpendicular, well, remember, you've got to take one of them, flip it, and change the sign and see if you get the other one. So if I take, and you can take either one of them, but if I take that one, that's the same thing as like 4/1. And so if that's 4/1, if I flip it, I would get 1/4. But then remember, you have to change the sign. And so if I change the sign, does that give me the other one? So are they what are called negative reciprocals? Are they flipped and the signs changed from one another? And if you looked at the beginning, the signs were the same. And so that would have told me that these aren't perpendicular either. So then these would be neither. So the answer would be neither, or if it said asked if they're intersecting, you would have wrote intersecting. Okay. So the last one here. Again, look to see if it's in slope-intercept form. So with number 6, when I look at my equations, neither one of them is in slope-intercept form. So before I move on to do this part, I have to put it in slope-intercept form. So I've got to get my y by itself. So with this one, I'm going to have to get my negative 2/3 x to the other side. So I'm going to add it to both sides. Okay. And so when I add that, and I'm going to just copy it over so you can see what I'm doing here. So when I add my 2/3 x, you have to do that to both sides. These will go away, and I'm left with negative y on the left. So make sure you don't ignore that negative in front. And then I'm going to pull my 2/3 x to the front, and it's positive, so I can just leave it as positive, and then that's a plus 5. Okay, And then I have a negative in front of y. This is the same thing as -1 times y. So to get that negative away, I have to divide both sides by -1. Okay, so the -1 over -1 will go away, and then I'll be left with y equals. When you divide two things by a number, you just divide each part by that number. So 2/3 x divided by -1, that's going to be a -2/3 x. And then 5 divided by -1 would be -5. Okay, so my slope here is the number in front of x. So that'd be -2/3 is the slope here. Now I have to do the same thing for this one. I've got to get my y by itself. This one's a little easier. The only thing you have to do is get this 3/2 x to the other side. So I'm going to subtract my 3/2 x because it's a positive and I'm adding it to the y. So you have to do that to both sides. These will go away. And then I'm left with my y. So y equals, and then I'm going to put the x part in front. So it's -3/2 x. And then that plus 8 I just put behind, all right? So again, I look at the number in front of x because the y is by itself and it's already in slope-intercept form. So the number in front of x is -3/2. I'm going to compare them, okay? So when I compare them, the slope of this one, again, you can write it to the side, is -2/3. The slope of that one is -3/2, all right? Are they the exact same number? No. So then they're not parallel. Are they opposite signs and flipped from one another? Well, if you look, they are flipped from one another, but they don't have different signs. So that means they're not perpendicular because it has to be both. It has to have opposite signs and they have to be like flipped fractions from one another. So they're not perpendicular. So then our only other option, these would also be neither, or intersecting lines.